Hey everyone, and welcome. Today we're going to jump into some incredible innovations that are quietly moving beyond our screens to fundamentally reshape the world we live in. We're talking about materials that can actually heal themselves, AI that understands emotion, and technology that is quite literally rewriting life itself. All right, let's get into it. So just keep that question in your mind as we go through this, because, that's not science fiction anymore. That's the future these technologies are building, starting with the very environment right around us. All right, so first up, we're looking at how our physical world is getting a massive upgrade. These are the innovations you'll actually be able to see and touch, and they're going to transform everything from the displays we look at to the very materials our stuff is made of. Okay, so let's break this down, because this is the next huge leap for all our screens. We're all familiar with OLED, right? Well, the future is MicroLED. And here's why it matters. They use inorganic compounds. In simple terms, that means they're more stable, they don't degrade over time, so they last longer. And, crucially, they don't suffer from that dreaded screen burn-in. This is exactly why companies like Samsung and Apple are pushing so hard to get this tech into everything. And this isn't just about making better TV screens. It's about screens kind of disappearing into our environment altogether. Just imagine your car's windshield showing you navigation data directly on the glass, or a surgeon interacting with a holographic 3D model of an organ. LG and Samsung are already showing off prototypes of this stuff, turning boring, passive surfaces into active, interactive interfaces. I mean, seriously, this one sounds like it's straight out of a superhero movie. Researchers are developing materials that can autonomously patch tiny cracks in airplane parts. LG Chem has already created a coating that makes scratches on a car literally disappear with a little bit of heat. It won't be long before that cracked phone screen might just fix itself right there in your pocket. We're also upgrading how technology interacts with us. It's called emotion AI, or affective computing, and it's designed to understand not just what you say, but how you say it, by analyzing your tone, your facial cues, all of it. They're testing it in cars to detect if a driver is getting drowsy, and in healthcare to spot early signs of stress. And that massive $49 billion projection, that tells you just how big this is about to get. Now, let's talk about something we can all relate to. Education. For centuries, we've had this traditional one-size-fits-all model. And let's be honest, it just doesn't work for every learning style. But what if your learning tools could adapt directly to you? And boom, here's the solution. Hyper-personalized AI tutors are already here. Khan Academy's Khanmigo is a fantastic example. It acts as a personal guide for students while also being a helpful assistant for teachers. You've probably already seen this tech in action. It powers Duolingo's language lessons for over 80 million users. AI tutors are on track to become just as common as textbooks. All right, let's switch gears. We're moving from the tangible tech you can see and touch to the vast, invisible systems working in the background. Think of it like a kind of autopilot for our entire global infrastructure. When you hear the word autonomy, your mind probably jumps straight to self-driving cars. But the real revolution is so much bigger. It's happening across the entire supply chain. We're talking about autonomous drones already completing thousands of deliveries in China, fully electric and autonomous container ships operating in Europe, and self-driving trucks logging millions of pilot miles on US highways. It's everywhere. But here's the flip side. As our world gets more automated and connected, it also gets more vulnerable. And the cyber threats are scaling up dramatically. Just look at this number. Over 3,200 reported ransomware incidents in the US in 2023 alone. That's a huge jump and a stark reminder of what's at stake. The good news is our defenses are getting way smarter too. AI-driven security can spot weird anomalies and identify breaches in real time, long before a human could. And at the same time, we're developing what's called quantum-resistant encryption. Basically, new ways to secure our data that even the super powerful quantum computers of the future won't be able to crack. Another massive piece of this invisible infrastructure is blockchain. And listen, it is not just for cryptocurrency. It's a foundational technology for creating trust and verification in a digital world. And that $1.7 trillion figure? That's what analysts at PwC think it could add to the global economy. And most of that value is outside of finance. And this isn't just a theory. It's already happening. Major players are using it right now. Walmart uses blockchain to track produce from the farm all the way to the shelf to guarantee food safety. South Korea has rolled out a blockchain-based digital ID for its citizens, and the EU is piloting it to make cross-border customs way more efficient.
So all of this needs a powerful network to run on, right? Well, while most of us are still just getting used to 5G, the work on 6G is already well underway. We're probably looking at a commercial rollout around 2030, with speeds up to 100 times faster than 5G. That's the kind of power you need to create truly immersive, real-time digital worlds and support these massive networks of autonomous devices.
Okay, for this final section, we're going deep. I mean, really deep. This is where technology starts to merge with biology itself, and it raises some of the most profound questions about our future. This is about rewriting the very code of life.
Synthetic biology is pretty much exactly what it sounds like. Scientists are using AI and gene editing tools to literally program organisms to do new things. Think about engineering microbes to produce sustainable biofuels, or using that mRNA technology, which we all know from the COVID vaccines, to now treat cancer and rare genetic diseases. It's incredible. This slide shows a perfect example of how technology is transforming medicine on the tiniest scales. With nanomedicine, we can use these little nanosensors to detect cancer super early, just from a blood sample. Then, we can use nanoparticles to carry chemotherapy drugs directly to the tumor itself, which dramatically reduces all those awful side effects. Brain-computer interfaces get a lot of headlines, but the field of neurotechnology is actually much broader. Researchers are now using non-invasive techniques, and that's the key, no surgery required, to treat things like depression and PTSD. New wearable helmets can now monitor brain activity with incredible detail, opening up a whole new world for personalized brain therapies.
And this really is the ultimate question, isn't it? As we gain the ability to engineer biology and interface directly with our own nervous system, that line between what's natural and what's created by us starts to get really, really blurry.
So, what's the big takeaway here? From our remastered physical world to the invisible autopilot running our industries, all the way to rewriting biology itself, innovation is embedding itself into the very fabric of our reality. The future isn't just something we're going to watch on a screen anymore. It's the world we're actually going to live in. A world that can see, think, and yes, even heal itself.